Over the last few decades, military conscription data from Norway and Finland has revealed a measurable population-level decline in human IQ. This chart reveals a specific divergence. Crystallized knowledge, stored facts, and vocabulary remain stable. Fluid reasoning, by contrast, drops sharply. Fluid reasoning is the capacity to hold abstract models, manipulate concepts, and observe your own cognitive process. This reflexive machinery is actively eroding. This measurable cognitive decline is occurring right now, during the absolute highest density of information connectivity in human history. Sustaining deep focus historically required physical institutional spaces, libraries, archives, and university halls, designed to insulate the mind from immediate external stimuli. Modern digital environments lack this insulation, instead producing rapid attention decay, exhaustion, and a diminished capacity for concentration. This cognitive fracturing represents a thermodynamic outcome driven by absolute energy limits. Reflexive cognition, the ability to monitor and modify one's own thinking, exists as an expensive, fragile achievement. It requires the brain to maintain simultaneous representations of an object and the self-model, a state that is metabolically and attentionally demanding. Scaling this capability requires cognitive scaffolding, the physical infrastructure of education and archives, and the discretionary time provided when a population is freed from subsistence labor. This infrastructure depends entirely on high energy return on energy invested, or EROI, to fund its maintenance. As energy returns contract, society enters regime 3, a state where the digital systems deployed to replace degrading physical scaffolding consume more reflexive capacity than they yield. To understand the fragmentation of modern intelligence, we must calculate the material energy bill required to sustain the extended human mind. Throughout human history, cognitive capacity scaled in direct proportion to the ability to extract surplus energy from the environment. The agricultural transition provided a return that was visible, storable, and extractable. This coerced grain surplus funded the first dedicated cognitive specialists, the scribes and accountants who managed the state's inventories. Extractable surplus allowed for a massive reorganization of labor, creating the administrative layers and discretionary time necessary for high-level abstraction. The fossil fuel age provided an energy surplus that subsidized universal education, massive research institutions, and the cognitive expansion known as the Flynn effect. High-density energy physically separated human labor from the immediate demands of survival, replacing muscle with mechanical work. This separation creates distance, the energetic buffer that allows human thought to operate decoupled from the local and the immediate. Discretionary time and abstract thought represent the most energetically expensive artifacts a civilization can produce. EROI dictates the exact fraction of total energy available to power society once the energy system has consumed its own share for production. This is the net energy cliff. While the top of the curve provides a stable plateau of surplus, the function breaks into a steep exponential drop once returns fall below 5-to-1. During peak oil, returns often reached 50-to-1. At these levels, the energy system remains largely invisible to the broader economy. Below the 5-to-1 threshold, the system reaches a cascade failure point, where the energy required to maintain production begins to cannibalize societal surplus. Global useful stage fossil fuels currently operate at a ratio of roughly 3.5-to-1, placing our energy base far down the vertical face of the cliff. The industry appears highly productive in gross terms, but the usable net energy delivered to society is actively collapsing. Our modern civilization is sliding down the net energy cliff, causing vast amounts of societal surplus to vanish. This creates a thermodynamic trap called the Red Queen syndrome, where the system must consume more energy just to stay level. Nearly 90% of current upstream oil and gas investment is now used to offset the natural decline of existing fields, rather than generating new growth. Water substrates follow a similar pattern. Depleting aquifers demand deeper wells and more energy-intensive pumping to maintain agricultural outputs. Topsoil loss forces a reliance on fossil-derived fertilizers to maintain caloric yields, turning the food system into an energy sink. As mineral ore grades collapse, the energy required per extracted ton rises exponentially, further draining the available surplus. The energy overhead required to maintain degrading physical infrastructure has cannibalized the surplus previously used to fund the scaffolding of thought. As physical scaffolding goes unfunded, society substitutes it with the cheapest alternative, digital platforms. These systems exhibit negative cognitive EROE, costing more executive function and emotional regulation to engage with than they return in actual insight. The physical result is dopamine receptor downregulation and cascading attention residue, leaving the brain in a state of constant deficit. This manifests neurologically as a hyperactive connection between the default mode network and the subgenual prefrontal cortex. The self-observing machinery of the brain runs consumptively, failing to exit negative loops. This state drives rumination, doom scrolling, and the subjective exhaustion of thinking hard while achieving nothing. We are undergoing a thermodynamic inversion. Our compensatory systems are eating our reflexive capacity. Competing theories attribute cognitive decline to test prep education, ultra-processed diets, and screen time substitution. Absolute energy decline acts as the primary driver, rendering these competing theories as downstream symptoms of a single tightening constraint. Declining surplus forces society to substitute expensive physical and cognitive inputs with cheap, low-yield throughputs across every sector. Psychometric data from recent student samples reveals a weakening of the positive manifold, the statistical correlation between different types of mental tasks. The G factor itself, the binding coherence of human intelligence, is structurally disintegrating, a process that transcends simple score declines in isolated cognitive traits. Reflexive integration degrades before any single ability bottoms out, which results in a profound unbinding of the mind. Because reflexive integration represents the most surplus-dependent operation of the human mind, it is the first capacity to disintegrate as energy limits tighten. The substrates consumed to build industrial-scale intelligence regenerate on geological timescales, but were burned on industrial ones. No currently practicable energy source can reproduce the extreme surplus ratios of the mid-20th century. Regime 3 describes a permanent thermodynamic descent. We are locked in a recursive trap. The deeper the energy deficit, the more we rely on digital extraction, which further strips away the capacity for sustained focus. And the ultimate tragedy of energy decline is that the capacity to measure the collapse and model a way out is exactly what the system is currently consuming.